right, welcome to our Unit 7 for Algebra Honors. Unit 7 is our unit on polynomials. This is day 1, but it's the second video, so we've gotten through some of our notes for day 1, and this is the second portion. We're going to multiply a monomial by a polynomial. So remember, a monomial means that we have one term. Polynomial means that we have one or more terms. Okay, so when we want to multiply a monomial and a polynomial, we're going to distribute the expression outside of the parentheses to each term inside the parentheses. Okay, so this is assuming there's more than one term inside the parentheses. For exponents, you're going to remember that if you multiply two exponents with the same base, if you multiply two variables that have the same base, you keep the base and you add the exponents. Okay, so we're going to do a bunch of math and then we are going to rearrange our answer to make sure that it follows standard form. Standard form again, we're going to do alphabetical order if we have more than one variable and we want the highest exponent first as our first term. Okay, this first problem, it really is a monomial times a monomial. So I will not be distributing this -7. Really, I'm not distributing it. I'm multiplying -7 times the stuff inside. Okay, there's no addition or subtraction, so it gets to multiply exactly one time, right? It's not being distributed, it's just multiplying. So you could imagine that this was -7 times 5 times x times y to the 4th if you wanted to. Okay, it's just all of those things being multiplied together. Once I multiply -7 times 5, I get -35, and that's it. Okay, I'm not going to keep multiplying the -7 times other stuff because that's just not how we do that. So -7 times 5 I can multiply because they're both numbers, so I have -35, and it's still times x times y to the 4th. Okay, so that's all we're doing here. This is our final answer. You can think of it also, if you had like 3 times 2 times 4, so that it's not weird numbers and variables, you know that this is the same as 3 times 8. It's 24, right? So I can either write that as 3 times 8, which is 24, or I can write it as, if I wanted to, I could call it 3 times 2 first times 4. 3 times 2 is 6, and 6 times 4 is 24. I'm still only multiplying each thing once, okay? So just be careful of that. There was no actual distribution here. All right, with this example, I'm actually wanting the negative of everything inside there. So I'm going to multiply -1 times each of these terms. There are 3 terms inside here. That's why we have distribution this time. Okay, here there is only one term inside the parentheses. That's why we didn't actually distribute. Okay, so I have -1 times 5x squared, right, is -5x squared. -1 times 5x is -5x. So I'm just subtracting 5x. And then -1 times -1 is +1. All right, so when I do these multiplication problems, I think to myself, I can multiply numbers together because I certainly know how to do that. I can multiply variables together because I keep the base and I just add exponents. And if I'm multiplying more than one variable, that's okay because I'm just multiplying straight along, right? I have -3a cubed b times 2a squared. The numbers I can multiply are -3 and 2. So -3 times 2 is -6. And then I have a cubed times a squared. So I'm going to keep my base, a, and I'm going to add 3 plus 2 and get a to the 5th. Okay, times b. So I've taken care of -3a cubed times b times 2a squared. Now, I go to my second term. So again, -3a cubed b times all of that. I can multiply numbers together. -3 times 4 is -12. There's my -12. And I can multiply a cubed times, no other a's. So I'm just going to write a cubed because I didn't change it. B times b is going to give me b squared. Third term, because I'm distributing outer information to each term inside. -3 times -7 is +21. A cubed just stays a cubed because there aren't any a's in this term, and then b times b to the 4th, I'm going to say is b to the 1 plus 4, which is b to the 5. Okay, now, standard form. I want to go alphabetical. So my a is what I care about, and then I want the highest exponent. A to the 5th is the highest. Next I have a to the 3rd and a to the 3rd. So this is where we get a little bit more complicated. Did I mess that up? Let's check and see. No, I didn't. So we're a little more complicated, and so we have a to the 3rd b squared, and we have a to the 3rd b to the 5th. I'm going to tell you that on a test for me in my class, I'm not going to be really hung up once you have more than one variable. So I could argue either way, whether we have b squared in the middle or b squared at the end. So I'm going to leave you with this as a fine answer. How about that? Okay, so we are going to use distributive property. Okay, I'm going to say k times k is k times k, keep the base, and add those invisible exponents, so it's k squared. Okay, and then I have k times -9, so it's minus 9k. Okay, over here, number 2, x times x squared, x to the 1 times x squared, I'm going to keep my base and add my exponents, minus x times x, which is x squared, and then x times 3, I'm going to add 3x. Okay, I'm checking to make sure I'm in the right order, and so there's only one variable, so I go in descending order for my exponents. Also, the leading coefficient for this guy would be 1, right? The leading coefficient for that guy would be 1. All right, let's take a look here. -4 times g squared times 2 times g. So the numbers I can do, -4 times 2 is -8. G squared times g is going to be g to the 3rd. Now I have to take that whole outer thing and multiply it times 7. So -4 times 7 is -28 times g squared, doesn't change. This leading coefficient is -8, right? All right. Over here, I'm distributing. I have -3n times n squared. So -3 times n squared is -3 times n to the 1 plus 2 is 3. My next term is going to be -3n times -2n. So I have the numbers, -3 times -2 is +6, and n times n is n squared. Finally, -3n times 8. It's -3 times n times 8, so -3 times 8 I can do, and I get -24 times n. Okay, you can try these next ones on your own if you'd like. So you can pause. So here, p squared q cubed times p to the 5th q squared. I'm going to do the things that I can do. I know that if I'm multiplying all this together, I have p squared times p to the 5th. Keep your base, add the exponents. Q cubed times q squared, I'm going to keep my base and add 3 plus 2 and get 5. Now I'm going to be multiplying p squared q cubed times -p cubed. So it's going to subtract. My p squared times p is p to the 3rd. Q cubed times q is q to the 4th. All right, -6p times p to the 4th is -6p to the 1 plus 4 is 5. -6p times -8 is +48 times p. All right, so it's just a matter of trying to be methodical and keep track. We have numbers that we can multiply together for sure, and if we have the same exact variable, we can keep the base and add the exponents. So I'm going to say -7 times 9 is -63. C cubed times c squared is c to the 5th. D squared times d squared is d to the 4th. Now I have -7c cubed d squared. And I'm going to multiply it times -4 cd to the 5th. I get 28 c to the 4th d to the 7th. Okay, number 8. Just got to multiply whatever's outside times every single term inside. Terms are things that are separated out by add or subtract, or also equals signs if we happen to have an equation. 5 times negative 2, I can do that math. 5 times negative 2 is negative 10. R squared times R squared is R to the 4th, and then S squared, right? Because it's all just multiplied together. 5R squared S squared times 3 RS. Multiply 5 times 3 and get 15. R squared times R, I get R to the 3rd, and S squared times S, I get S to the 3rd. And then I have 5 times negative 4 is negative 20. R squared just stays R squared, and S squared times S squared is S to the 4th. So alphabetically, I'm going to take a look. R is first in the alphabet, and so I just want to make sure I'm in descending order according to my first letter, R to the 4th, R to the 3rd, R squared. Yay. All right, so now you have to work back to previous units and remember how we simplify. So if I have a big expression like this, in order to simplify this, I have to distribute. I have to do this multiplication first. Okay, that's because I have variables. If these were just numbers, we could use GEMDAS, right? And we would take care of everything in the parentheses first, then multiply, then add. But we have variables, so we can't exactly do that. I'm going to distribute negative 2x times 3x. So negative 2 times 3 is negative 6, and x times x is x squared. Negative 2x times negative 4 is positive 8x. And then I didn't do anything with 7x anymore. So I don't keep distributing this negative 2 once I hit the parentheses. All right, now I need to see if I can combine like terms, and I can. So I have negative 6x squared plus 15x. Okay, this next one, it's complicated. Let me make sure I'm in standard form because it says that standard form. It is x is the only variable and x squared is first and x is second. That's fine. Okay, let's distribute. Y times y is y squared. Y times 4 is 4y. This is negative y that I am distributing. Okay, be really careful when you've got negatives. So negative y times y, it's negative because it's a negative times a positive, which is a negative, and then y times y is y squared. Negative y times negative 3, negative times a negative is a positive, y times 3 is 3y. And then I subtract 9y. Okay, now I need to simplify and combine like terms. So I have y squared and I have negative y squared. Any more y squareds? Nope. Y squared minus y squared, poof, they're gone. Yeah, that's just 0. 4y plus 3y is 7y, minus 9y is negative 2y. So that should be the end of that. All right, so last page. We just get a little bit more complicated each time sometimes, and so I've got two variables happening here, and I just need to multiply and combine where I can. So 2y times 6x. I can multiply those numbers together. 2 times 6 is 12. Y times x, I'm going to write it as x times y, so it's alphabetical in that, within the term, okay? Now I have 2y times negative 4x squared y. I can multiply 2 times negative 4, that's negative 8. Y times x squared y, I'm going to have x squared y squared. Okay with that? Because that's y to the 1 times y to the 1. All right, so I've distributed, and now I'm just going to bring down everything else. So I kind of did all my distribution. Now I'm looking for like terms. 12xy. Is anybody else 12xy? Nope. So I'm just going to bring that down. I have negative 8x squared y squared, but I also have positive 13x squared y squared. So those I can combine. That's positive, that's plus 5x squared y squared. And then minus 6. Okay, it's not in the right order though. So the first alphabetical letter is x. So I need my x term to be first, my highest x degree. So x squared right here, right? So I'm going to say that that's 5x squared y squared plus 12xy minus 6. Now it's in the right order. All right, here, oof, whole lot of stuff going on, but that's okay. I can do it. 4x squared times 2x squared. 4 times 2 is 8. X squared times x squared is x to the 4th. 4x squared times x, it's really 4 times 1, right? There's an invisible 1, so that's 4. And then x squared times x is x cubed. And then I have 4x squared times negative 5, so 4 times negative 5 is negative 20 times x squared. Okay, I've done that distribution, but look, I have more to distribute. This negative x has to go to everybody over here. Okay, negative x times x cubed. It's negative 1 times positive 1. It's a negative number, right? Negative. Then I have x to the 1 times x to the 3rd, so it's going to be x to the 4th. Now I have negative x times 5x squared, so negative 1 times 5 is negative 5. X times x squared is x cubed. Uh-oh, I'm going to hit my hole punch there. So I now have negative x times negative 3. It's going to be plus 3x, yeah? Negative times negative is positive, and 3 times x is 3x. Okay, I'm going to combine like terms where I can, so I have 8x to the 4th minus x to the 4th is 7x to the 4th. I have 4x cubed and negative 5x cubed, so that's minus 1x cubed. And then I have negative 20x squared. Nothing else matches that guy. And then finally, just that, 3x. So that should be the end of it. I am in alphabetical order because there's only one variable letter, and I'm in descending exponents. All right, so I need to find the area of the shaded region. Right? So for the shaded region, it's this big rectangle, but then I have to subtract all that white stuff. So I'm going to say big rectangle area minus small rectangle. That's what I'm looking for, right? See how that is? Okay, so my big area of the shaded, the whole big rectangle, area big, B for big, is going to be 6x times 8x minus 1, right? It's length times width. Okay, so I know the area of my big rectangle is 6x times 8x, so it's 48x squared. I'm distributing, and 6x times negative 1 is negative 6x. That's my area of my big rectangle. My area of my small rectangle is going to be just that stuff. So it's 2x times 5x plus 3. See? This area small rectangle. So 2x times 5x is 10x squared. 2x times 3 is 6x. Okay. I need area big minus area small. So 48x squared minus 6x, that's the area big, minus area small. Because I'm subtracting, I have to use parentheses because I'm subtracting that whole thing. So what it means is I'm going to have to distribute that negative. So I have 48x squared minus 6x minus 10x squared minus 6x. Please be careful here because I know you can see minus 6x minus 6x. That is minus 12x in the end, right? It doesn't cancel out. So don't go too fast. 48x squared minus 10x squared is 38x squared. Okay, and negative 6x minus 6x more is minus 12x. That's the difference between the area of the big and the area of the small. All right, so a little bit of quick review. Try these reviews on your own and then check your work. And if you've forgotten completely, you can watch the first few and then pause and try them. Okay, if I'm dividing, I'm using this rule, x to the m over x to the n equals x to the m minus n. You will also see me do this where I say the bigger exponent minus the smaller exponent, and whatever that answer is, I'm going to put it wherever the bigger exponent started. Okay, so I do both of these. That way I don't have negative exponents in my answer. K to the 8 over k to the 3 is k to the 8 minus 3, which is k to the 5th. Okay, m cubed over m cubed, anything divided by itself is 1. A to the 6 over a squared is going to be a to the 6 minus 2, which is a to the 4th. B to the 4th over b to the 3rd is going to be b to the 4 minus 3, which is this b to the 1. And I just write it as b. Okay, 6x to the 4th over 2x cubed. Well, if it's numbers to deal with, I can say 6 divided by 2. I know that math. And then x to the 4th over x to the 3rd is going to be x to the 4 minus 3, which is just x to the 1. Here, 14 over 7 is 2. X squared over x is x. Y squared over y is y. All right, let's see what we've got here. I have 15x to the 6th y to the 5th z. Oh, it's negative. Don't lose your negative. And it's over 3x to the 5th y to the 3rd. So 15 over 3 is 5, and it's negative 5. X to the 6th over x to the 5th. 6 minus 5 is 1, so it's just x. Y to the 5 over y to the 3, it's going to be y squared. And then z, didn't have to divide anything. All right. So that was just kind of dividing a monomial by a monomial, which we have done. Now, of course, there's more. So now I'm going to divide a polynomial. So it could be one or more terms. I'm going to divide a polynomial by a monomial. Okay, so to divide a polynomial by a monomial, we're going to divide each term in the numerator by the denominator. Okay, so 6x plus 4 is my numerator over 2. So I know that that's going to be 6x divided by 2, so that's 3x, right? 6 divided by 2 is 3, but also 4 divided by 2. So 3x plus 2 is my answer. You really could break that up and say it's 6x over 2 plus 4 over 2 if you wanted to. Okay, 9x minus 27 all over 3. I'm going to divide every term in my numerator by that denominator. So 9x divided by 3, I can do 9 divided by 3, that's 3x. Negative 27 divided by 3 is negative 9. Okay, this time I have 3 terms in my fraction, and so I'm in my numerator, so I'm going to divide every single term up there by 5. 35x squared divided by 5 is 7x squared. 25x divided by 5 is 5x. And 15 divided by 5 is 3. Okay, x to the 6th over x squared, that's going to be x to the 6 minus 2, so it's x to the 4th. And x to the 3rd over x squared is going to be x to the 3 minus 2, which is just x. All right, so that'll do it. Thank you so much for watching, and join us for the day 2 notes.